Hi, this is Alex with Spectrum Networks, and today we're going to walk through strip lighting assembly. Everything you see here, aside from the piece that's already been cut, is exactly what you need to create your own cut-to-length strip light assembly. So let's talk about the spool, since this is how your cut-to-length order would be received. A 5-meter roll, similar to this one, you simply lay it out and cut the length you need, making sure that you cut along the copper cut marks that you see here. It's a simple process that gives you total control over the exact length you need in 2.5-inch increments for this specific strip. So now let's set this aside and go back to the strip I had already pre-cut. This one happens to be a 10-inch segment, and I've also pre-cut a piece of our low-profile bendable aluminum extrusion to 9 inches, 1 inch shorter than the light strip itself, so that the FTECs can connect properly. However, before we bond the strip into the extrusion, we'll need to prep the contacts on each side. And when I say prep, I mean we need to remove the waterproof silicone coating over the contacts so that our FTECs can make a solid, reliable electrical connection. Speaking of FTECs, or field termination end caps, these are the connectors that let you reliably terminate the strip right in the field. They come in 3 different variations: a plug, a receptacle, and a passive end cap. They're fantastic tools that give installers unprecedented flexibility, enabling them to use the full length of the strip and minimize waste. Okay, now let's get back to prepping the strip so we can bond it to the extrusion. What we're going to do is remove about 11 millimeters of silicone to expose the contacts underneath, which ends up being roughly 1.5 times the width of this provided little blue scraper tool. The process is pretty straightforward. Press the tool down about 11 millimeters from the edge of the strip, cutting into the silicone along the LED dome, being careful not to hit the LEDs, and then just scrape it away to reveal the contacts underneath, like you see here. Pretty simple. And that's really it for this step. You can see that the silicone is removed and the electrical contacts below are exposed. There's still a bit of residual silicone on the contacts themselves, but we'll take care of that in a later step. For now, I'll grab an FTEC and just confirm that the amount of silicone that we removed is correct, and it looks good. So now we're ready to move on and prep the other side. Now on this side, you'll notice a couple of small components we need to be mindful of, but otherwise we're doing the exact same steps as before. We'll cut about 11 millimeters from the edge of the strip, run the tool along the LED dome, again making sure not to hit the LEDs, and then scrape the silicone away to expose the contacts below. Same process as the other side, we just take a little extra care around those components. So once the silicone's been removed and everything looks good, before we move on, I'm going to take a moment and use a nylon brush to clean both sides of the strip. This just helps knock off any leftover silicone that might be stuck to the surface, and actually is very similar to what we'll be doing shortly to clean the remaining residue off the copper contacts. But for now, as you can see, both sides look nice and clean, and we're ready for the next step. So now we're going to remove the adhesive backing and bond the strip to the aluminum extrusion. But before we do that, we're going to lay the strip face down and use the extrusion as a guide to lightly score the adhesive backing on each side, about 3/4 of an inch from the edge. This lets us peel away just the center section of the adhesive while leaving the red VHB liners intact along the edges. And we'll come back to why that matters a little later when we install the FTECs. Once the adhesive backing is removed, which I'm not going to show here, you'll slide one side of the strip into the extrusion, making sure it's centered and that you have about a 1/2 inch of overhang on each side. This is the time to make any adjustments if needed. Once you're happy with the alignment, start pressing the strip into the extrusion. You'll notice it's a snug fit, but it slides right into place as you apply pressure along the length, just like this. And here's what the completed strip looks like. You can now see we did a good job keeping it centered with that 1/2 inch overhang on each side. Now we're ready for the next step, prepping the contacts for an FTEC. And speaking of FTECs, one thing to keep in mind is that they're directional. You'll see the arrows on the sides of each FTEC, and those arrows should line up with the arrows printed on each segment of our strip light. And while it's definitely not recommended to hot plug strip lights, because doing so can potentially damage them, for the purposes of this video, I'll be hot plugging the segments so you can clearly see the FTECs in action. Now, as I mentioned earlier, each strip needs a bit of extra preparation to ensure a solid electrical connection. But before we do that, I want to show you what happens if you connect an FTEC to a strip that hasn't been properly prepared. You'll notice the light flickers a bit. That's because it's not making a clean electrical connection. And even though we removed most of the silicone earlier, there's still a thin residue on the copper contacts that needs to come off. To do that, we use a tool called a scratch brush and lightly brush along the copper pads to remove that remaining residue. Now, once the contacts have been cleaned with the scratch brush, I'll go back in with the nylon brush to knock off any remaining silicone. And as you can see, the copper pads look great, almost like they've been polished. And that's exactly what we want for a solid electrical connection. Now let's reconnect the FTEC and check the results. Light comes on instantly with no flicker, so we're good to go. So now let's talk about the clips. These are really straightforward to install, and we recommend placing them about every 6 to 8 inches. The aluminum extrusion simply snaps into place. As you can see here, it grabs onto the lip along the side and keeps the extrusion from releasing. It's a simple process, and it's actually quite strong. I've set a few of these out on the desktop so that I can show you how a light strip clips in once the FTEC has been installed. Next, I'll grab an FTEC and slide it onto the strip, making sure the arrows line up and that it's pressed as far forward as it can go. Once you've checked electrical continuity, you apply a bead of RTV around the edge of the FTEC, and that side is complete. Now we're ready to move on to the other side. Once again, we'll slide the FTEC onto the strip, and this is exactly why we left those red VHB liners in place. They let us push the FTEC all the way forward without it sticking prematurely. Ensure the arrows are all aligned, confirm electrical continuity, RTV around the edge of the FTEC, and this strip is now complete and ready to be dropped into place. Next, we'll perform the same steps on the next strip, sliding the FTEC onto the strip and ensuring the arrows are all aligned and that the FTEC is pressed as far forward onto the strip as it can go. Now, since this strip is our end segment, we'll actually be putting a passive end cap on it. The process for the passive end cap is the same. You slide the FTEC onto the strip, ensuring it's pressed as far forward as it can go, RTV around the edges, and this strip is now sealed and ready to be dropped into place. And once again, although it's definitely not recommended to hot plug strips, for the purposes of this video, I'll be hot plugging the segment so you can clearly see the FTECs in action. So I'll plug this first FTEC into our controller, which lights up our first strip. Then I'll connect the two pigtails, which lights up the remaining strip, make any final adjustments, and you're done.